Good morning. In the previous section of the demo, we saw how the data consumer is able to access the anonymized data and consume it in downstream applications. And in this section of the demo, we shall look a little bit under the hood and see what's the setup that's required to implement the anonymization process that the consumer is able to leverage. We will have four sections of the demo. First, we'll look at what's the setup required to enforce dynamic anonymization. Thereafter, we will look at the implementation steps for a static anonymization flow, followed by the governance and the maintainability aspects of this setup. Now, in Cloud Pak for data, the proposed solution for the tender, governance or automated governance can be implemented in three simple steps. In step one, the business glossary is ingested into the system. Now, this business glossary typically consists of things like business terms, classifications, data classes, and reference data. Business terms identifies the business entity. It standardizes the name of the business entity or the attribute and generally maps to a column name in a particular table. Classifications of data generally signifies the confidentiality of the data and may have different classes like PII or sensitive or classified or confidential or secret or whatever the case may be. Data classes typically define the format of the data, how the data looks like. Say, for example, NRIC looks like the character S followed by 7 digits followed by 1 character, whatever the case may be. Reference data typically maps to master data or any kind of reference data sets that you want to use to enforce some kind of data validation or data quality checks or other parameters. Now, in addition to this step, the other step that's required is defining the policies and the rules. Now, these policies could be regulatory policies, or it could be organization policies, could be data privacy policies, and they're typically paper policies, but they can have associated rules, and the rules can be actually enforceable. And a typical example of a rule would be that if a data class is this, then handle it in a certain manner, or if the data has this business term, then mask it or anonymize it or redact it or obfuscate it. So these could be examples of rules. Now, that's all that is required as part of the setup to implement the anonymization in the system. Once these two are done, in step 3, the system will automatically extract the physical metadata of the tables and the hosts and the columns, and then harvest that technical metadata and ingest it into the system. And while it does that, it will map it automatically to the business glossary that we have uploaded in the previous step. The mapping or the matching is done typically by comparing the column names with the business terms that's defined, or by comparing the column values with the data classes that's defined. And the end result of this would be creation of a catalog or multiple catalogs, which can be consumed by downstream users, as we saw in the previous demo. Now, the other key aspect of the system would be how to enforce governance. So you may have to consider having some kind of gates at required intervals in this process, which will ensure that there's some kind of validation or scrutiny that's happening, or some approval kind of process that's happening before artifacts are getting published to the catalog for broader consumption. And this is generally implemented through a workflow which can be configurable, and later on in the demo we shall see how it's implemented in the system. Now, the key differentiation in our proposed solution is making this entire implementation of data privacy seamless and with minimal amount of overhead maintenance, overhead work required. And we achieve this by bringing in two key aspects of the solution. One is around industry accelerators and the other is around automation. Now, what are industry accelerators? Industry accelerators typically are a set of industry specific business terms and categories that's already kind of predefined and curated. Say, for example, we have industry accelerators for healthcare and for telco and finance and for many other different industries, which can be readily leveraged upon. So you don't have to start building business terms and categories and other metadata from scratch. We can leverage this and modify this as required based on our requirement. Similarly, in terms of data classes, out of the box, the system will provide 140 plus pre-built data classes, which will generally provide the formats of commonly used data elements in the business. And these new data classes, if required, can be complemented or supplemented on top of it. In addition, there will be a lot of like pre-built data quality rules, which are predefined in the system, which can be leveraged, and additional rules can be defined. Now, in addition to these accelerators, we do support the entire automation of this entire setup process from step 1 to step 3 all the way by making available a rich set of APIs. And leveraging these APIs, this setup and maintenance of the entire governance process can be automated such that the end result of this would be having an intelligent data fabric that can ensure that the right data is available to the right consumer with the right set of data privacy rules enforced automatically behind the scene without the need of having a lot of overhead maintenance activity to make sure that the process is running fine. So with that background, let us now move to the actual demo and see how it works in the system. The fundamental mechanism by which the anonymized data is shared with external stakeholders in the proposed solution is by this construct called catalogs. Now, there could be many different catalogs created in the system based on the target audience in mind. Usually, there would be one catalog which is enterprise-wide catalog and is called a platform catalog. And normally, all stakeholders would have access to this platform catalog, and it will contain public information for general consumption. Now, in addition to that, we can have additional catalogs created for specific target user groups. And some of these catalogs may contain data in raw format, like in clear text. And for those catalogs, we can specify not to enforce any data policies. And obviously, such catalogs will not be given access to the general community, and we may want to control who has access to the catalog. And obviously, this set of user groups could be data stewards or data owners who can see the data in clear text. But additionally, for the larger audience who needs to see only anonymized data, we can have targeted catalogs created for them. And in those catalogs, we will ensure that we have enforced the data policies so that the fields which are sensitive appears in anonymized or masked manner. And then you can go ahead and assign access to the target users or user groups to the respective catalogs. Now, having defined your catalogs based on your target audience, it is time to go into the step 1 of our setup, where we define our business or governance business glossary or governance assets. Now, we can maintain all these assets like categories, terms, classification, data classes, etc. from the system out here itself. For example, like in business terms, we said which defines business entities or business attributes. We can maintain it here. We can add business term manually through the GUI, or if the business terms are available in the form of a CSV or something, it can be straight away ingested into the system from here. Now, as we said, IBM does provide the entire set of business terms and categories for the healthcare industry, and we can just ingest or import that over using this import mechanism. And once it is done, all the relevant business terms needed for the healthcare industry will be made available. Now, of course, based on your specific scenarios, you can go ahead and make changes to these terms, or you can go ahead and add additional terms as the case may be. So likewise, you can maintain other glossary artifacts or other governance artifacts like classifications, data classes, reference data, or for that matter, anything else. For example, data classes which signifies the format of the data or how the data looks like, can also be defined in a similar manner. So here, for example, we have, say, a data class called NRIC, and we can see how it identifies the format of the data. So the key thing is the data matching method, and you can specify a matching method for each of your data class. So here, for example, NRIC stipulates that it starts with S followed by numeric digits, 7 of them, followed by a single character, and any data which matches this format will be tagged as a data class called NRIC. Now there could be different types of matching formats that you can choose from. If you have a list of valid values like a reference set, and you want to make sure that it matches with that reference set, then you can use that as a matching method. If you have master data and you want to make sure that the data matches with the master data, you can use that. Or for that matter, you can use any kind of regular expression like the one we used here. And then if you have a completely custom logic to do the matching of the data format, then you can also externalize it in a Java class and embed the Java class and specify the Java class, in which case this whole thing can be extended into that custom logic, and the matching can be done based on the criteria set in that custom logic. Or you can have any other type of matching criteria based on column name matching or a mix of column name and formats. So having defined the matching method, you can publish this data class, and then any data format that matches this kind of class definition, or the data format definition, will be tagged with that particular data class. So this completes our step 1 of the setup, in which we have defined the business terms, the classifications, data classes, and thereafter we can move to the step 2 of the setup that we talked about, where we are defining our business policies and the underlying rules. Now, policies can be are usually like paper policies. They could be things like GDPR or PDPA, or data privacy policies of the organization, of how certain data has to be handled in certain manner. So here, for example, we have a personal identifiable information policy, and it has a hierarchical structure. It has sub policies underneath, one sub policy around data sharing and one sub policy around data protection, and you can have sub policies like these, and all these are paper policies. But the important thing is that these policies and sub policies can have associated rules, and the rules are not paper rules. The data protection rules can be enforceable. So here, for example, we can see a bunch of data protection rules, like say mask, name and address. The construct of these rules has this structure like an if then else kind of structure. So you have a criteria, and if the criteria is satisfied, then you have an action. So the criteria is generally built using the governance artifact that we created in step 1. So here, for example, we have defined a criteria here based on a data class, and we are saying that if the data class contains any of these formats, the data contains any of these formats, then how do we handle it? Then obfuscate the data in columns containing these data classes. So there could be different ways in which we may want to handle or take the action based on the requirement. Now that was a case in which we were doing obfuscation of the data, but we can have another example where we are handling it in a different manner. So here, for example, we are handling IDs. So a bunch of IDs is what we have taken: driver's license or passport number or internet protocol address, URL or whatever. And then we are saying if it falls into any of these data classes, then substitute the data, which means it will preserve the format, but it will change the value of columns containing these data classes. Now, building these rules are pretty straightforward. You can just say create a new rule, and you can, if you want it to be enforceable, then you can create data protection rule. Data governance rules are usually meant for documentation purposes. You can give the rule a name. Say, for example, I can say this is, say, I want to do mask SSN, and then I can go ahead and in the rule builder I can create the rule condition and action. So the condition, as we said, is created based on the governance artifacts that we created. So it could be based on business term or based on the asset owner, or you can make it completely generic and make it based on a custom tag, or based on user roles or user names or classifications or data classes. So let's take the example where we say, okay, it's based on a data class, and we can say, okay, data class contains, and you can pick up a data class which we have already defined. Say, for example, if this is SSN, we can say if data class contains a US Social Security number, then what do I want to do with it? I can completely deny access, or if I want, I can mask the data. And what is the criteria? We can say we can mask the data based on the data class Social Security number. Now, then you can go ahead and specify the type of masking that you want to do. If you want to do obfuscation, which is basically format preserving replacement with similar values, you can choose that, or you may choose to just convert it into an equivalent hash based on a hash key, all these numbers, or you may just want to replace it with specified character. And depending upon what type of method you choose, you can have advanced masking options. So for example, you can choose if you're doing a redaction, you can choose things like what is the character with which you want to redact, whether you want to redact partially or whether you want to redact completely, and things like the number of masking characters. Maybe you want to mask the first four or last four characters and things like those. Similarly, if you want to do obfuscation, you can also specify whether you want to preserve the format or not, or you don't want to preserve the format but just want to replace the letters and the characters with equivalent with equivalent values, and then specify whether you want to make it irreversible masking or reversible masking. In case of a reversible masking, you can specify an encryption key, and such encryption keys can be maintained in an external key management system. And then you can also specify whether you want to make it repeatable, that is, it will consistently mask the same value to the same anonymized value, or you want to make it completely random so that it is irreversible in nature. And then finally, you can also specify whether you want to do input validation on the data, which will validate the value of the field with the data class that it is defined, and if the value matches, then only it will go ahead with the anonymization. So like this, you can define a pretty rich set of data protection rules, and once these rules are defined, they will automatically apply to all catalogs which has specified in the setting that data protection rules has to be enforced. Now that completes step 2 of our setup. Now once we have completed the step 1 and step 2, we can go ahead and now to enforce the rules that we created in the previous steps, we need the catalogs. We need to build the catalogs, and that brings us to the step 3 of the setup, where we go ahead and create these catalogs of the data sources. And we do this by running these discovery processes in the system. Now, discovery can be done by connecting to a platform connection or a connection to a particular data source. So we can set up an automated discovery job by selecting a specific connection, and either we can choose to harvest the entire connection, that is the entire data source, or a subset of it, or a specific schema inside the data source, or a specific set of tables if that's the requirement. And then the end result of this can be stored in a particular project. Now we can also specify things like, as part of the discovery process, whether it should analyze each and every column of each and every table, and if it does that, we can choose to specify some kind of sampling criteria if the table is huge. In addition, we can specify whether it should also analyze the quality of the data and compare the completeness of the data in comparison with certain data quality rules. And in the process, it can also assign all the business terms and the data classes that we have defined. And finally, we can specify whether we want to publish the results to a catalog or not. Now, having defined all these configurations, we can go ahead and run the data discovery job. And what would happen is it would run through the extraction and harvesting process and the matching of the physical metadata with the business metadata and give us the result of the discovery. So here, for example, we have executed a discovery process on a particular connection, and we have discovered one table, and it shows that the patient table, it has a 96% data quality, and it has has been assigned with 100% confidence with a particular business term called patient, and we can drill down and get into the individual column level details, and we can see here that it has actually calculated the data quality of each individual columns. It has mapped the columns to specific data classes, and it has also assigned the business terms associated with the column names, and it shows the degree of confidence with which it has mapped it. And in cases where the degree of confidence is not high enough, then it has not automatically done the mapping, but then it can be done manually as part of a review process out here. So the end result of this would be creation of the catalog and publish of all this metadata in the catalog. And if those catalogs are set to data enforcement rules, enforcement of data rules, then automatically all the rules that we have defined will get enforced based on all the mapping of the business terms and the data classes that the discovery process comes up with. So this completes our first section on a dynamic setup. And in the next section, we will look at how we can implement a static masking flow. Let us now move on to static anonymization. Now, static anonymization is implemented in the system within the projects using data flows. The solution offers multiple options to build these data flows. So you can choose to use a completely wizard-driven IDE or tool, such as a masking flow, to build these kind of data flows. Or if you so desire, you can choose to use canvas-based IDEs, drag and drop IDEs, such as a data stage flow or a modular flow, to build these flows. Or alternatively, if you so desire, you can also use a completely code-based IDE, such as a Jupyter Notebook or a Jupyter Lab or RStudio or other scripting interfaces provided by the system. Now, if you want, you can even choose an IDE outside this solution, such as say an Informatica flow or something else, and still leverage the masking functions provided by the solution, which can be exposed as a web service and can be invoked from an external system to get the anonymization done. And each of these options will create a masked copy of the source data and save it in a target environment of your choice. So let us now look at some of these different examples and see how we can use those to build masking flows. So let us start with the simplest one, which is the wizard-driven one, which is a masking flow. Now, as we said, masking flow is a simple tool for end business user kind of profile usage. Now, in this, all we need to specify is what is the source data, which needs to be anonymized, and give a pointer to that source data. And then you specify things like if there are any filter conditions that needs to be applied on the source data. Say, for example, I want to create a masking flow for any age patients, and I can provide a filter condition such as provider name is any age. And then you can go ahead and create a job based on this. And as part of the job setup, you can specify the target where the data, the anonymized data will be saved, specify the schedule at which the job will run, and then go ahead and execute the job and schedule it to run on regular basis. So like we said, this is a very simple tool for end business user kind of usage. Now for slightly more advanced users, you can use canvas-based toolings. And using canvas-based toolings, you can implement the same kind of masking flows. So here, for example, we have implemented a masking flow using a data stage IDE, and data stage is a canvas-based IDE with drag and drop kind of operators available with which we can create these kind of flows. Now, in this particular example, we have mapped the source to the source patient data as using the JDBC operator, and then using the hierarchical operator, we are invoking a masking function which has been exposed as a web service, and that does the masking operation. And the end result, the post masked data, the end result of it is saved in a tokenized patient table, and we have mapped it to that table using again a target JDBC operator. Now, the hierarchical stage in data stage allows us to invoke REST endpoints. So here, for example, we are invoking this particular REST endpoint, and in the REST endpoint, we are invoking a particular method. So this is what has been implemented using Guardium tokenization function, and then using that function, we can implement a different types of web services, such as one for tokenization, one for detokenization, and then those can be called from masking flows such as these, or external masking flows to get the anonymization done. And the end result of this would be saved in a table called tokenized patient. So if I execute this job, then the result that would result in a table called tokenized patient, which we can make available in the project. And if we preview that table, we would be able to see that the particular field that we are tokenizing, or the set of fields that we are tokenizing, will come as with the corresponding encrypted values, instead of being like clear text values. So this is another way by which we can implement tokenization or masking flows for static kind of use cases. Now, irrespective of whichever method we use, all these can be converted to jobs, and then the jobs can be scheduled to get the data refreshed on a regular basis. So this is one example of such a job. So if we look at this job, then we can see that this job actually yeah, so this job, for example, invokes a script called to_tokenize, and this to_tokenize uses a Python runtime. So that translates this is a Python script, and then it is scheduled to run as per a predefined schedule, and will create the output file as per the configuration. It'll take some input parameters and create an output file based on the definitions of the based on how the script is configured. So this is an example where the same masking flow has been created using a Python script called to_tokenize. So if you want to analyze this Python script, we can go back to the project, and we can take a look at how a script can be used to create the same kind of masking flows. So let us go to to_tokenize here, and this is implemented as a notebook leveraging a Python runtime. So like the previous masking flows that we saw implemented using masking flows and data stage, now this particular script also is reading an input data, and the input data can be a CSV or a DB2. For DB2, it's the patient table, and if it's a CSV, it's a CSV file. And then it is invoking the same Guardium tokenization web service, and either it is doing a tokenization function or it is performing a detokenization function, and then it is storing the output in the tokenized patient output table. So if we follow the steps, we can go through the logic of this notebook. So essentially, this is where it is reading the input data set and then mapping it to a data set here, pandas data frame here, and we can see everything is in clear text available. Everything is in clear text, and then it is applying the tokenize function. It is defining the tokenize function using the URL that we have configured earlier, and then it's invoking that function. And once the function is invoked, then post tokenization, the pandas data frame, the result can be assigned to another pandas data frame, and then here we can see that SSN and other fields that needs to be tokenized has been converted into encrypted form. And the end result of this resultant data frame can then be saved into the target table based on the output table definition that we have defined. And then you can generate a pre versus post tokenization view, and we can compare these views and see which all fields have been tokenized, and then we can take these kind of views and we can publish it into an operations dashboard to reflect the degree of anonymization and generate other type of matrices that are required. So likewise, the same thing can be done from an external IDE, like if you are using Informatica, or for that matter, if you have any other real-time kind of flows, you can invoke these kind of web services, the tokenization web services, and get the tokenization done in real time and proceed with the rest of your data flow or real-time flow, whatever the case may be. So with that, we will finish this section of the demo. In this section, we saw what are the setups that's required for implementing the dynamic anonymization behind the scene in real time without making any copies of data. And we also saw the different mechanisms by which a static anonymization can be implemented in the system using a plethora of tools that's available. And we also saw how the proposed solution can expose these tokenization functions as web services and make it available for external systems to leverage. So with that, I will end my section of the demo and pass it over to the next speaker, who will talk about the setup in the clinics and how tokenization or how anonymization will be performed by the clinics within their own environment.